Before we proceed with our brainflow real-time plot project, let's explore a program that demonstrates how painter and mouse events work with egui. This is the struct used in the eframe run native function, which has only one field. The central panel is filled with resize containers, and a painter is allocated for this container, with the response stored in a variable called response. A frame is drawn for the container. Please note that the resize container is positioned 8 points away from the border of the application window. To draw a circle with its center in the middle of the container, we adjust the x and y coordinates by 8 points, as all positions are relative to the entire window. The second resize area is similar with minor differences. In the third resize area, we use a different approach to draw a circle. We consider the position of the top left corner as the offset. Add this offset to the relative position of the circle center, and then draw the circle. If we add a label here, the resize containers will shift downward, but the first two circles will remain in their original positions. Let's add a field named showLabel to the myApp struct. In the update method, we will add a side panel position to the right of the application window. The side panel will contain a button that toggles the variable showLabel. Let's compile and run the program. Let's focus on mouse events like click and drag. In the third resize area, we utilize the input method implemented for the UI struct to track the mouse position. Let's execute the application. The code responsible for detecting mouse positions is independent of any resize areas, so it's cleaner to place the closure and input call outside the scope of any resize areas. Next, we'll test how cursor positions are extracted from the response instance of the first resize area. The first resize area responds to both click and drag. When testing the response from the second resize area, it is responsive to click but not drag. Now, let's discuss our real-time plotting project. Currently, we use a field called plt_ctx to create and store plot information, abstracting implementation details from programmers. The real-time plotting functionality is handled by instances of the plot struct, which are created using a method of the plt_ctx field. I propose simplifying the code by eliminating the plt_ctx struct. Instead, we will incorporate the hash map that stores plot information as a field within the myapp struct, with the default being empty. Plot information will now be created or retrieved here and used for creating plot instances. To add visual variety, we will define a constant called colors as a list of 16 colors, with each plot using one of these colors. Let's compile and run the program to see the changes in action.